Hello, folks. It's George Leoniak at New Geometry. And today I'm super excited to be here. I have a very special presentation that I've been working on, all set up for the whole week. It's going to be on the golden matrix of infinity, a super duper fantastic form that has literally come out of the ether. And ether is a good way to describe it because it is made up of 21 dodecahedron as well as some icosahedral caps that ran out of pieces. This took every zone tool part of this size. There's icosahedron in here. We've got the stellated dodecas. I mean, we got everything in here. This is a phenomenal structure that is making a large dodecahedron. So as usual, I've got a presentation set up that's gonna got tons of slides, tons of these pictures. I got a multitude of other forms that I'm surrounded here with that I'll be sharing with you throughout the presentation. I have pictures of all those. And big thanks to everybody out there who's subscribing to my channel. I have hit 1K today, 1,000 subscribers. So this has definitely been working on a special video just for that. And it just happened to coincided with this amazing golden matrix of infinity video. So once again, here's the structures. And you know, if you've watched any of my videos, I love to correlate the 3D geometry with the accurate geometry as produced in the circle templates with the golden ratio circles. And you know, this is what I'm calling a kind of golden vector matrix, really. And I'm going to compare that a little bit to the isotropic vector matrix, which is the 64 tetrahedron grid of Nassim's Haramein work. A little bit later on, not too much on that, but because every single division within this matrix will infinitely expand in every direction of space, creating all the Platonic solids within this infinitely through these connection points of these golden ratio segments, the vectors that are created throughout that. And I'm also going to talk a little bit about, in just the next slide or so, about Dan Winter's implosion, explosion, fractality, and how that relates, because essentially this large form that I just had in hand and showed you that we're looking at now from the top down pentagon is actually his star mother model. But now just picture his star mother model with every single dodecahedron there, and of course going everywhere, completely having the implosive capability, and explosive too, I guess I like to call it, because it's also expansive as well as imploding inwardly. So let's continue on. I've got different views. That was from the Pentagon view. Primarily throughout this video, I'm going to focus on all these drawings from the hexagonal view, which is the view of the flower of life, the seed of life, fruit of life, is a common sacred geometry perspective or images that we see regularly. And I just want to illustrate that when we switch to this view, and in many of my videos, I talk about Metatron's cube and the dodecahedron isn't drawn accurately and the icosahedron isn't drawn accurately. And I've got a few good ones. Metatron's cube distorts the Platonic solids, or the phi ratio forms, that is. Icosahedron and dodecahedron. Metatron's cube does not contain all 5 Platonic solids. Those 2 videos, check that out. But this is why I've been saying that it's more than just doing like a perfect drawing. I mean, it is nice to have an accurate drawing of the form. And I was just focusing on one of those dodecahedron or one icosahedron all that time. There's no way you can do this in Metatron's cube without adding these phi ratio circles, because now I have to draw all these dodecahedron that I see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I got 21 dodecahedron and a little one in the middle with icosahedron mix. So it's just not possible. This is why this is an expansive KNEW geometry to start working with, because this is just scratching the surface here, I feel like. But anyway, remember this golden hexagon, which I've just really enamored with here, has really been in most expansive, two-dimensional flat shape, polygon shape. And you could see the golden hexagon right here. And you could see the fractality of this tree pattern in this. This is from another video I did on the dodecahedron and the golden hexagon that's within it, because every dodecahedron has a golden hexagon in it. And here it is, the outline of this multitude of dodecahedron. And so let's see. Now I wanted to just touch base on the two things, and I don't really know how either of these Dan or Nassim here would feel about this, bringing their two things together. Maybe they already consider them completely unified. But at least in my drawing of sacred geometry, when I worked with the 64 tetrahedron grid, I found out that, the icosahedron, the dodecahedron, without the phi ratio circles, just in the flower of life, I wasn't able to integrate the other Platonic solids, the phi-based forms, into it. And I pretty much did the cube, octahedron, tetrahedrons endlessly, the buckyballs or the little magnetic blocks, which I started with having these. And I just build out endless and endless and endless, all the same length struts. This is isotropic, meaning it's gonna just be the same in every single direction. But you see the golden vector matrix is not the same in every direction. It's a divine matrix, divine proportion-based matrix, which is based on the golden ratio. And in fact, I guess Greg Braden wrote a book called The Divine Matrix. And I would imagine that this golden ratio matrix that I'm describing right now would have a strong affinity and affiliation with something that expands within golden proportion. So we have that, and I did a lot of many drawings. Here it is in the Metatron's tetraplex, another video where I talk about 30 forms that can be drawn in the tetraplex, kind of evolution of the cube, Metatron's cube to the tetraplex, which is a 4D shape. But then, I also did some videos with Dan Winter's Star Mother, and I have another form I created called the Star Child. And, Dan's work really started to get how all these forms, especially the phi ratio ones, interrelated and how they all implode or explode. And as in the drawing, starting off from a small octahedron in the middle, you got the tetra, the star tetrahedrons, you got cube, dodeca, you got the small stellated dodeca, you've got the icosahedron, the great stellated dodeca, which he calls the stellated icosahedron. And then we go all the way out to the dodeca again. And I got a whole video on this where I show you that that is infinite and forever. We'll continue to do that. The only thing I had a difficult time now reconciling is, well, okay, I've got that outward inward movement through just this central point, but what about all the other circles, right? Because all the other circles are going on with, the 64 tetrahedron grid. Every little point in space can do something like that, implosive. But with this, I know Dan's probably sees it happening that way, but I wasn't able to depict it that way. But this is now when this came along, right? This is now each little dodeca within this. You picture each of these having that implosive, explosive capability. And this doesn't just end at this, and I'll show you how in just a moment. This is not a finite form here. This is an infinite form here. A while back, I discovered this form, and I kind of just knew there was something more to it, because I started to see that these were icosahedron by themselves, but this is a 5-cube compound. And as I've often said, in every dodecahedron, there are 5 cubes in it, really common knowledge. We got 5 cubes in this shape, creating the vertices of this. And, I was like, okay, well, I've got an unusual compound of an icosahedron, the big lighter blue shape, with the dodecahedron, which is not round, I haven't connected the lines here, but that's a 5-cube compound, which would be this form if I connected those lines. So I had that, I had it built, I had to deconstruct it, and it became this that's over here to my left that I just showed you. Anyway, but then I started to discover that each of these little caps, here are the golden hexagon shapes, they're right on there, right? Here's a golden hexagon dead center, right? Because this is how I discovered how important that golden hexagon is. But then when I knew that the golden hexagon was inside, a cross section of the dodecahedron, I realized that every single one of these golden hexagons are themselves dodecahedron, and each of these pentagonal faces are icosahedron, and they have infinite contracting space inside of smaller dodecahedrons and larger icosahedrons without. And I got to say that this really all emerged from this circle template that I've talked about. This is a while ago, I talked about this one. It has a name now, the golden matrix of creation. or the golden matrix of infinity, or just the golden matrix, whatever works for you. But this is a golden matrix that is going to produce this type of expansive dodecahedron at every single whole circle within this, at multiple scales of phi ratio, because I can do the implosion explosion of phi ratio circles like this right here, this implosion model. I can do this implosion at every single, I'm doing that every single circle within this creation, flower of life, fruit of life design that we're familiar with. But now, to me, I've always said it really has the life to it, because you've added phi, and now I'm imploding and exploding at every single one of these points, the Dodeca and Icosahedron at multiple scale invariants, which is all the Platonic solids are showing up to the party here. It's, it's phenomenal. So, that then breaks the limitations in my mind of just working with the original hexagon view of just a flower of life as it is, because without the phi ratio, you are just drawing cubes and octahedrons and tetrahedrons and some truncations with the cube octahedron, which I'll talk about a little more too. But that's what's involved in that. Once you add a phi ratio, now we have the full complete creation going on, at least of the 5 Platonic solids, and many, many truncations and compounds of these forms. So as I'm saying, forms within forms within forms. I wanted to illustrate here, let's just take a piece of this segment here, right? So there's some extra lines here. I'm about to show you what's going on here. Let me pull this off as if I just removed this like crystalline, let's say, growth that is growing, maybe even quasi-crystal type of structure that's going on. We know that crystals in themselves, like quartz and all the elemental crystals that we're familiar with, they are isotropic in the same in every direction. And, the icosahedron, dodecahedron representations that we see of that, like grown in pyrite, actually have what's called pyritohedral symmetry, which makes them more related to the cube than to the phi ratio, but they're trying to be more phi oriented. But we do know that there are quasi-crystals, and we're trying to discover how those quasi-crystals might grow, or we've done a good amount of research on that. And those quasi-crystals do have phi ratio in it. So here's a little conglomeration, basically, that is pulled out of this infinite phi ratio creation dodecahedron over to the left. And as you can see, I've got interlocking small dodecahedron, these black lines, those are the edge of the cube. Here is a larger portion of dodecahedron, which is now going up inside this icosahedron. And now I've got this icosahedron, which is growing out of and off to the side of the larger icosahedron. And then way inside this here, which I didn't do any dodecas or icosas off of that, I'm showing you that the cube is all linked up in here. And then we got the star tetrahedron and the octahedron. And of course, we've got a larger cube and larger star tetrahedrons and everything throughout that. So it's really a lot more complex than just one thing going like this, or just cube next to cube next to cube. There's a lot more complexity. It's like, what type of compound do you call this? I mean, it's just an aggregate of this full this full creation. It's just a fragment of this endless pattern here that's presented itself. And like I said, I'll do this, and then I'll have the build right here, right? So I'm actually drawing as I'm looking at this aggregate, this this group, the clustered together, the congregation, I guess I called it congregation, because there's this little growth structure. I'll have to show you all these at the end. I know this just looks like a bunch of blue lines I'm holding up. But this is that same structure from that orientation, and there's the drawing. And I just must say again, which I'll probably say again and again in all these videos, and probably throughout this one, this is not really possible to even come close to drawing this without adding the phi ratio circles. So let me just unpack this one a little bit more for you. So here's all the lines all together. It's not like they're solids. Here they're intersecting and go in. So I'm going to simply unpack everything that's going on. And of course, there's other octahedrons and other tetrahedrons and cubes throughout this, but I'm just pulling the major ones that I showed you in that, so it doesn't get too complex. But here's the little purple octahedron and the little orange tetrahedrons that are in that cube. Here's that cube. This other cube here is the one that was portioned off of that dodecahedron down there. So that's that dodeca. And of course, we've got this icosahedron, which was growing outside of the big one, which also intersects the small dodeca and connects to that one. And then we got the big dodecahedron here, which is also has a cube in it. And they actually have 5 cubes, but I'm just showing you one. And that one goes through the center like this. And everything, it lines up because it's right there in my hands in the form. Right, and I've got a 3D model of it, and as much as the lines look complex, but then you got this big icosahedron, and this is why it's important. Like that pentagonal shape that goes across the back, if that were a straight line, like it is drawn in Metatron's cube, that has no back pentagon shape. That's just a flat triangle. So then there's no phi ratio in that. So if you want to start seeing more of the complexity of the creation as it really is, associated to phi ratio, if you really believe that phi ratio, or really know in your being that that's the truth, that these forms are the phi Platonic solids, the building blocks of creation, as you see with like every quote about the phi Platonic solids, the 5 building blocks of creation, well, then they need to be drawn like this, or they're not. It's kind of like that simple, because they won't do what it is that I'm showing you here, because that pentagon shape isn't present in it. So you're only building with cubes. And that's it. You got 1 cube universe. You don't have 5 cube universe or multitudes of cube universe. You have just the same cube, like children just putting blocks together. And maybe it's a lot more complex than that. And hey, I love playing with blocks, and that's a great way to start. But the children of the future will be building blocks like these. So we've got let's work now our way down. We're going to start to kind of shave off the outer things the next level in, right? So we're going to kind of take off those dodecahedron, right? We got those dodecahedron taken off the golden hexagon shape. So now we do have the external hull of just an icosahedron here. And then these are the little 12 icosahedron, because it's got 12 vertices, but each vertice now is actually a small little icosahedron that you can see right here, that are at each of those vertices. I got a better image of that in a second. And that creates the outline. And it's got all this kind of little bowl shape that goes down because it's connecting to the form. So this has got concavities. These lighter lines amidst the darker ones are sunken in. These are like ridges separating the two. Here it is. I've removed those outer struts so you can kind of just see the icosahedron that are off of this big central icosahedron. So that's why we got 13. But really, this is still very much an abstraction, because there's a lot more icosahedron that could be built in all these here. But this is as simplistic as I can make it to show what it looks like at this level. And already, like, this is a drawing that I did from a video months ago that was worth checking out, about the 12 icosahedron around 1, it's called. So I was already starting to do that. And that one in there, I show you from 3 other views, and I have a 3D modeling software where I rotate that around. So this is actually my early work on starting to get this video really brings together and kind of unifies so many different elements and threads that go back for 4 or 5 years of things that I've been working on subconsciously that have been coming to me to try and produce this, really, to make this type of discovery that I'm sharing today. And this was one of them. Like this golden hexagon shape, I actually found because of the giant geohedron structure of the Earth grid that I designed, not that I designed, but that I created the geohedron shape that's, got extra vertices, and I'll talk a little bit about it later. But this was the first form I ever created with the golden hexagons was this, pentagons and golden hexagons. And you're going to see why this is so important later on. But as we take off those icosahedral caps, right, we just take those off, then all of a sudden we come up with this. But because this was, I'm just viewing that the space is empty in this, I had no idea that this was going to have all this other geometry linked into it. It was just like hollow. And now I see that if you take off those icosahedron, you've got the remaining part of the icosahedron and the dodeca here. So that also has this kind of ridges and concavities to it. This was my early drawings of that form. And there I already did this, and I put the pentagon stars on this one rather than it kind of sinking into the back end of the icosahedron in there. But this form was really like a missing piece of the puzzle. It's a big part of this puzzle of how you're going to move from this truncated form, which is so different than the regular hexagon truncation, right? Because we have a truncated icosahedron, which is a regular hexagon, meaning all these hexagon edges are equal. And at that point, it doesn't do this expansive type of thing. It becomes maybe more of a storage type of unit. But it's hard for me. And when I actually tried drawing that, and I did draw it once, it fought so much against the phi ratio circles that were in there. I had to come up with so many different different ways of doing it. It was one of the more frustrating drawings that I've done. It was the most frustrating because working with the golden circles is like a joy. It's like so much on the edge of creative discovery that happens with these phi ratio circles. And if you don't know, like you see in this one here, this has got some extra circles here, and you're looking for a point. You have to divide a line in phi ratio. Well, just add a few phi ratio circles at key intersection points, and all of a sudden, you know, the magic starts happening because the phi ratio is the unity that is behind this whole pattern, really. So here's a form that I've never talked about in a video at all. And it's really like one of the most important forms in this whole structure. I did draw it months and months ago because it showed up and I was like, geez, I got to figure out how to draw that. And there's a much more easy way to draw it. I'm just making sure everything looks like it's connected to the original drawing. But this form is really special because it's a rhombi, icosy, dodecahedron, and it basically combines the three main polygon shapes that create all the Platonic solids, the squares, the triangles, and the pentagons. So it has all three of those. And the squares, there are 30 of those, and there's 20 for the triangles, and that would mean that it's related to the icosahedron, and 12 for the pentagons related to the dodecahedron, and then the 30 squares. So it's almost kind of like a cube octahedron kind of puffed out a little bit to fit in the pentagon, basically, in some ways. But it's got 30 squares instead of just 6, which actually, this is another video. It does make sense because there's 6 times 5, right? There's 5 cubes in this, and that little, this was another image that I was wanted to do. This square is part of a cube. If you put a cube around each of those little squares, a big one, that creates the dodecahedron again, a larger one. So this form is just within 5 cubes, basically. That's why there's 30 of them. So that's really the big thing with this, working with this phi ratio forms, is that everything becomes, you know, based on the 5-fold symmetry. So yeah, this is that form. The little cavities go in. That's going to connect to the icosahedron that's going to be underneath it. But I want to say a couple more things because this one connected to that crystalline growth, dodeca and icosa. See, that's just growing right off of this, and I just pulled it off because I was like, okay, this is going to be a little out of hand if this keeps going off. It could just go off in that one direction for kind of a while. So I filled out the backside and did that drawing, but it's going outward there, but now also internally into the structure, even though this might look like it's coming out towards you. I built an icosahedron into this form off of a triangular face. And these little squares, which I didn't show you here, but the little squares, if you build a cube on top of that, which I guess I'll show you in the next slide. If you build a cube on top of that, right, that cube will create the outline, create the one cube of a dodecahedron. And now you build a dodecahedron off that cube, and then magically that dodecahedron, the edges of it, which I'm not showing you, that will connect with every other single phi ratio division of all these stellations that are about to happen in this form. So basically what I'm showing you here is I'm stellating the rhombi icosy dodecahedron, and the triangular stellation points that you see are going to be the great stellated dodecahedron, which I showed you back at Dan Winter's slide. I'll show you that again. And the small stellated dodecahedron is going to be the ones off the pentagonal faces. And that stellation of those two, that actually will create the outline of this form. It creates the vertices, the outer vertices of this form right here. So that stellation of that rhombiicosy dodecahedron, it's not too hard one to roll off the tongue after a while, the rhombiicosy dodecahedron, it connects to these points all the way around. And that's what's kind of driving or imploding or exploding and driving that underneath geometry that is all connected to going through and parts of those other interconnected forms of the dodeca and the icosa. And remember, the cube and the tetra and the octahedron are all in there too. But this is what it looks like just on its own. I'm just showing you kind of a top portion of it. That's the same image, the red one here, and this is the small stellated one, which are both in the model. So these points are going to come out. This small stellated will be back there, but the small stellated that comes from the stellation of this rhombiicosy dodecahedron, that then is creating another dodecahedron in here of a different size, but that's then creating the top points of the icosahedron, the 12 icosahedron that are around this. So this might feel a little overwhelming if you're definitely new to my videos. If you've been with me for a while, it might actually also feel quite a bit of an expansion of the material that I've been presenting. It was definitely that for me this week, but it pulled together so many of the little tangent parallel paths that I'd been following. So this is the build of that I knew was one last piece I had to create for this morning. This is quite large because I had to use all the small struts were being used, so I had to use the big ones. And now this is it in the golden template, golden matrix circles here, right? So here are the blue ones. That is the small stellated. The red is the great stellated dodeca. And this one I had to flip upside down, so it looks like the floor is on the ceiling. But anyway, this connects, these points right here connect to the vertices that you see in the drawing. In fact, here is the horizontal line. If you follow this horizontal line, you'll see that it's making this star point. And that's just this is just the magic and beauty. And this is why I love transferring these 3D models to the 2D drawings, because they actually work together very well and they help me see things that I wouldn't see otherwise. And I think I really, work that skill by, the small amount of time I've been talking to Frank Chester, and definitely been influenced by his research. And I have a few video interviews with Frank, 2 of them that I think you might really enjoy checking out to learn more about his creative process. So here's the rhombiicosy dodecahedron from the 5-fold symmetry. Wow, what a sunburst type look. And this curvature of this circular circle that's going around here is just phenomenal, how that lines up like that. But actually, these are just a zigzag of straight lines actually going around, and the pentagon within the pentagon, the square faces. I mean, it's just a 3D mandala, right? That is part of this infinite golden structure of creation. And when we connect all these outer points, then we start to create all those other little dodecas. So I'm going to kind of breeze through the other ones, because a lot of those is really where I've been hanging out. This is kind of where we've been hanging out in the golden circle template as we built it out. The star mother and star child brought us a little bit beyond this point, out to that large dodeca for sure. And then the star child is built on the compound of the icosa and dodeca. That's a whole nother video, but all those geometry would fit into this as well. But this is the great dodecahedron, which is a very cool form with the greatening of the dodecahedron faces. Then we got the small stellated that's within that, creating the vertices within that. So that form is just within that. You take those stellation points off. Now you've got this little regular dodeca. We're way down in there now. Of course, I'm only showing one cube, but in other videos, I show you what all 5 cubes look like. Of course, we could have 10 tetrahedra in here as well. I'm just showing you one star tetrahedra, or still octangula, as Kepler called it. and one little octahedron way down at the center of that. So let's just put that all into perspective of how far we've expanded out from that one little octahedron, which I've put down into the middle of our drawing here. That is what we've done, and this is really just the start. But I love this because we do have the octahedron, the tetrahedron, and the cubes all within there, but all those octas and tetras now are not isotropic, meaning they're not all the same in every direction, meaning you'd have to get these sets made with phi ratio pieces. And that's a real recommendation to whoever makes these, is make these struts, that are not, the Zoom tool struts help us do this, but make these struts so that you can build these in a way that you can add different lengths. And then all of a sudden you're building two different size or multiply different size cubes. And then all of a sudden the icosahedron and dodecahedron will jive with that, because those cubes and octas and tetras are in phi relationship. So then all of a sudden they're coming to the party. And this is let me now jump into, we're going to do a little switch, and I have to give a complete picture of this. I mean, I could stop the video there, but I have more slides, at least 12 more. So if you need to take a break to take that in, but I have to just tell you how I got there, because this is the starting point, and this is based on the golden cube octahedron. And it's not probably really a cube octahedron, but it's based on the same geometry of the cube octahedron, but essentially adding the phi ratio to that cube octahedron so that it's built with golden ratio faces. And I did a lot on this cube octahedron in a video that only has like 100 views, called the universe, the dynamic steady state of the universe. The whole first half of that video, I was looking at Conrad Ranzin's rhombic dodecahedral structure of the universe. And before that, I got into this cube octahedron, this golden cube octahedron, and I compare it to this one, cube octahedron. And I believe what I believe we're looking at here is the structure of the universe with the phi ratio involved in it. So, I love for researchers or other people who really know this scientific models to really apply this, because if we go on saying that all these Platonic solids are part of the building blocks of creation, as I already previously said, I love to see the scientific validation and theories going along with that, because we have a lot going on in the direction of the cube octahedron with the isotropic vector matrix right now. And I really wonder what this golden hexagon version of that form is, because these are golden rectangle faces that are being produced. So let's go through these slides, because I built this out of just wire and cocktail straws. And this was the start of the major expansion, because I saw that it created a little tetrahedron down in the middle, right? So those crisscross of hexagon lines that are going through this form crisscross in such a way that it makes a tetrahedron rather than them just all landing at a central point, right? And that tetrahedron is going to be a cube that's going to be in relationship to a different size cube over here. And that's why this isn't the isotropic version. It's the golden vector matrix rather than the isotropic vector matrix. So here's this, and these are golden rectangle faces, and sacred geometers love the golden rectangle, right? I mean, it creates the phi ratio spiral built on phi ratio, rather than the Fibonacci version of it, right? That's our closest approximation without using decimal points in our in the pattern of repeating numbers. But this is just a golden rectangle that would be built into larger and larger golden rectangles. So from that process, what happened was I said I really studied this little wire form for a while, and I noticed there was this concave shape off this golden rectangle that went into it. And you could see right here in this picture that I put it in there, and then I was like, well, it must have one maybe going on the outside. So I just stuck one on the outside, and I built it all the way around like that, and basically just put together what this little form here up at the top, that basically was constructed as hollow space mostly. In fact, I think this little funny looking shape could just be the most expansive infinitely shape of the whole thing. And I'll show you why in just a few slides. But this little structure creates so much. And it created a truncated tetrahedron, basically. So if we put a tetrahedron here, here, and here, it would just be a full tetrahedron, but it's got all this negative space. And, you know, of course, I like to expand, I build it out, I put a bunch of them together, and then I come up with something that actually holds two tetrahedrons, you know, like just by placing these edge to edge like this and putting them all together, this hollow space in between these created this star tetrahedron in the middle. And here, of course, is the drawing of that. And 1-for-1 accuracy with the drawing. And this rotated that whole dodecahedral perspective back to the orientation of the cube, because now all of a sudden our star tetrahedron in the cube is straight on facing you. So here is, and I'll show you these at the end, here is the model of that. It's super cool. It's so reminiscent of the isotropic vector matrix, the 64 tetrahedron grid. I even made a little flap on it here so I could open it up and you could see that I could pull out this tetrahedron right here that was just inside that little hollow space. So each of those are like that. And the one that they're all off of course, is the octahedron, which is in the middle. I'll take this whole thing apart at the very end, and we're getting there soon. So thanks for sticking with me. Okay, here's just a nice drawing of it, or what's a little bit more color. So you can kind of maybe see here the golden hexagon faces. Here's the red tetrahedron coming up towards you. The blue is the one going down. You don't see the backside. And these are kind of like octahedron that are like tetrahedrons and octahedrons together that are kind of coming together to create those central cubes. It's such a fascinating structure. So this was great because I never knew I could make this out of the Zoom tools. So I actually then, with these teal colored Zoom tools, made it out of these intersection. And here the yellow balls are all the cube points. So all the yellow balls create the star points. All right, so that's the same structure as this. And then I was like, well, hey, I could just build a golden hexagon golden cube octahedron. I'll put 8 of them around. And this is 8 golden cube octahedron that have gone around this structure, essentially making kind of like a cube out of this. And actually has an octahedron that shows up in here. And this is so cool that the old artwork that I did from 4 years ago, I had to go upstairs. I was like, hey, that's that same cross. I was trying to draw this back then before I really knew anything about the phi ratio. And these are probably not phi ratio accurate at all. But this is now the important part of why this structure played into this, because I discovered within that little golden cube octahedron matrix, which is they're probably not they're not probably cube octahedrons, but whatever we want to call this form that looks like a cube octahedron with the rectangular golden rectangle faces, they created the vertices to create the dodecahedron and the icosahedron. It just provided it, right? It was like this shape, the regular cube octahedron, you have to kind of, like the jitterbug, which is over there, you have to crank it to the side, you have to twist it in order to get the vertices. But when you have vertices of the icosahedron and the dodecahedron, but if it's just like this and isotropically going off in every direction, there's no vertice in this that's going to give you the golden ratio. It's just the same length, edge length everywhere. So all of a sudden, when I've made this golden with the golden rectangle faces, then all of a sudden, whoa, hey, there's the icosahedron and dodecahedron showed up, right? And the black dots are those golden rectangle faces of those cube octahedron shapes. There's 8 of them in there now. And they are now providing, as I stellate the icosahedron, you have to stellate, well, you have to send a line off of that central octahedron out to give you the icosahedron, and the dodecahedron comes right off of the inner core of that. So those faces end right at those. But then I was like, well, wait a second, what about the other faces of the icosahedron? Okay. So bear with me. I'm kind of just working through my process because this helps you just understand that I didn't just make this, start putting pieces together to build this. It wasn't like I just said, hey, I'll just give me a few hundred of these pieces and this is what will come to be. I had to work through this process to get there. And along the way, making some very, very interesting discoveries. Because what I had to do was I had to actually make a cube that was of two of these golden rhombus, golden rectangle cube octahedron. They were actually not just one, like this is one by itself and it's just in the cube. This one I needed two. I needed one up and one down. And that would create this outline that would be a truncated version of it. And then you add these little points and then it creates a cube. So I know that might sound a little complicated, but when you do that, you are going to build a larger cube. This is like a truncated cube, meaning the edges of the eight corners have been cut off, creating this kind of octagon shape. And all of a sudden, that little form is way down in the middle because you've sent those lines out to connect to those far vertices. And the neat thing about that is that the star tetrahedron, remember the one golden rectangle by itself, or the golden hexagon by itself, that created just one of those tetrahedron in that, right? There's only one tetrahedron in this golden hexagon shape of the cube octahedron. But if you have the other one going down, well, then all of a sudden, the two of them together create that tetrahedron at the center of the structure. But the big thing that happened here was that all of a sudden, that is the outline of a dodecahedron. All of a sudden, the cube, this outline of what will be a cube when I stellate those, this will turn into a regular cube. It now has become the shape of a dodecahedron, which just kind of like, I knew this a while ago and I put it off to the side because I didn't know what to do with it. But now I understand a little bit more because it will be in phi ratio basically. And if I take that shape off, there's the dodecahedron underneath it. And there is that truncated cube that was right on top. And those two views, like this is not compatible. This doesn't just go over top like I just showed you. You have to choose, if you're drawing this, you have to choose one or the other to do that. Because this, if you're drawing the dodecahedron and all the five-fold symmetry that comes off that, this whole cube and star in the middle has to be slanted. One has to be slanted. It's either going to be the dodeca, angle to the side, and the cube will be straight, or the cube will be straight on to you, the hexagon, and that will be oriented. So these were not compatible over top of one another. You have to choose one or the other, but realize that if you go with the five-fold symmetry, then it's much easier to draw everything else. Like all those little dodecas that I showed you in the very, very first slide, which you'll see again, all the 21 of them in the icosahedron, they'll all fit into these circular spaces, where if I go about it this way, the whole pattern just goes awry. It pretty much just showed me a portion of what I needed in the puzzle to make further discoveries that little shape, this shape here was part of it. So I built that too. I built the double cube octahedron, the double golden cube octahedron, right, together, up and down. So that's this structure is over there, but too big to show on the screen. So one's up, one's down. And that created this structure. And there's the blue star tetrahedron and the red lines are the connecting lines. And that's going through the center of this. And this is all part of this golden matrix, right? This is all internal geometry that's happening. You're not able to produce it with the regular cube octahedron. So I had to find out how the cube integrated into the other phi ratio structures. And it had to be golden. It had to be golden. This structure had to be golden. Not to say that it's not in there, because we do have cubes and octahedrons in there. But in order for it to integrate with the other phi-based structures in five-fold symmetry, this little form had to come to be. And what happens when you do that is Now you have a bigger cross, big crossing of two golden rectangles, because remember, one of those cube octahedron, the golden one, it just had one golden rectangle face. But now when I take the other one and flip-flop it and it's going down, think star tetrahedron, because that's essentially what this is. This is a star tetrahedron going up and going down, or one tetrahedron going down, one going up. And that's the idea of it, at least. And then when those two cross, the two golden rectangles cross, and that creates this pattern that's essential to the internal structure of that giant golden infinity matrix. There's so many titles that I'm throwing around now that it's hard for me to keep track of them all. I'll throw around just a few more, but okay, I wanted to share that piece because it's an important little piece. I think the main takeaway is if you're drawing this, that the cube is now oriented straight onto you, and the dodecahedron in this would be tilted over to the side. But the other way around, if this is part of the dodecahedron or the icosahedron, where that's the outline of the hexagon, this shape in the drawings is going to be tilted. It's just the way it works. But I had to figure out, like, what does that structure do? Like when you are going to turn it into rather just being one cube into 5 cubes, because now it's basically a compound of that structure. There's 5 of them now, 5. It's a compound of 5 or 10 of these, right? This golden hexagon cube octahedron, 5 of, or 10, I guess you could call it 10, but 5 of that cross shape that I just showed previously, 5 of whatever we want to call these, 5 of those, and they are now inside this structure. And as they go around, I was like, oh, wow, I'm creating a new form. And then I realized, wait a second, this is back to this my first golden hexagon structure that I ever made. I'm back to this one, the truncated icosahedron with the golden hexagon faces. And that was like an epiphany for me, because I had just done, and here's the Zone 2 build, and I rotated around. I took out all the internal struts. I'll show you what it looked like before that. But here's the outline of it, golden hexagon faces. Here's the pentagons. There's the structure below. I started to build it out. All these had triangles in it at some point. I took them out. But all this then created this. Now, this relates to this other compound of the cube octahedron that I just did a video on, 5 cube octahedron. I did a compound of 5 cube octahedron because it was part of the geohedron. I now call this the equilibrator because it's a device that's a balancing, I find, or that it seems to be, because this is all about perfect balance, this cube octahedron. So, but check this out. There's a relationship now between this cube octahedron and this one, the golden one to the regular one, because when I do the golden hexagon and I do a compound of that shape, these all line up with the pentagons. But what happens with the regular cube octahedron, it also produces golden hexagons. They're part of these star edges, and it's outlined in red. That red shape is a golden hexagon that was also created within this outline of the equilibrator, which I just did a video on and talked about how it creates that little channel between the grating of golden hexagon faces. So it was just so interesting to me that the phi ratio compound of those golden cube octahedron didn't grate in the faces. It was actually the baseline. This was the baseline shape. It created the integral structure that was part of this. Whereas I grate in the cube octahedron faces, they overshot the edge, the seam, right? They overshot the golden hexagon seam. They did produce a golden hexagon, and then they created the star that would be inside the star of the dodecahedron that's larger. It's just amazing how the geometry all works out like that. But that then showed me that there was a relationship between the golden cube octahedron and the regular cube octahedron in the compounds of the two. So I think a lot of the geometry that I'm presenting, especially as it's relating to the cube, is demonstrating as it relates, excuse me, to the compound of these forms, because we have to, in geometry with phi ratio forms, the icosahedron and dodecahedron are built on the phi-fold symmetry. So the cube within those dodecas have to follow suit. But that discovery then led me, this is how I finally get back to where I started with you. Once I discovered that then there was tetrahedron that were growing off of each of those dodecahedron golden hexagon faces. Here's a golden hexagon face. Then all of a sudden I was like, wait a second, those are each cubes. So I have actually 20 cubes around this central form, the central icosahedron, dodecahedron that's down in here. There's actually 20 cubes here and more within it, but 20 cubes, large cubes, that then I just was like, wow, that big dodecahedron that I got here, really all I need to do is just create dodecahedron on every single one of those golden hexagon faces. The golden hexagon in there is the yellow balls. I know there's a lot of them in there, but that black dot that's going right towards you is a golden hex, part of the dodecahedron. And then this yellow one and yellow one down here, that's every single one of those golden hexagon. If I just, added this golden hexagon face, if I just built the dodecahedron off of this and internally into the structure, then all of a sudden I create 20 dodecahedron. And that's how I got there, really. And then it was building models for literally all week long, and doing the drawings to try and describe this to you. And I hope that, I know that was a lot, probably maybe longer than my normal videos, which are long anyway. So this might be on the long end of things. But I wanted to provide a very special video for 1K subscribers. I was so thankful. It was kind of my, when I had 993 just a few days ago, I was like, I really hope I have 1,000 for Sunday, because that's what I was aiming for today to do the video. And so when I woke up today and saw it was still 998, I was a little like, oh, geez, am I going to get it? And then literally 20 to 30 minutes later, there was 1K subscribers. So thank you all for watching my channel. I hope you really appreciate the videos that I'm putting out, and that you find them expansive and they're helping you understand and relate to sacred geometry that you're seeing and relating to regularly that's out there, and also introducing a lot of new material, new NEW and KNEW. And I want to just end, and then I'll do a final wrap up and show you some of the forms. That these are the patterns that have kind of evolved for me, that I'm finding the most significance from this hexagonal perspective. I have the seed, flower, fruit of life, and I think nearly everybody who enters into the world of sacred geometry, or even if they don't know anything about it, they've probably seen this pattern. The circles of the same size that go on and on and on. And, that is the same as this pattern here, and it's the same as this pattern here. The only difference between all these other patterns is that I've integrated in the phi ratio circles. In every drawing that you've seen in this, and in fact, my ability to create and work with these forms is so instructed by the drawing of sacred geometry as it relates to these forms, and going back and forth to see more from the 3D to 2D and 2D to 3D, that it's just an essential part of the process. But it really came from this very first initial discovery of this pattern right here, the golden circle seed of life. Shortly after that, I did the golden matrix of creation, which I call it now. But originally it was to create, it essentially created the form that I talked about today. I just didn't realize it was 20 dodecahedron. So, but this was the first initial layout of that with all the golden ratio circles. And the thing I love about that is that will go out, horizontally, and expansively up and down. But the larger the circles get, the more capability you have to kind of jump to the next phi level in the scale invariance. And that's where the Dan Winters, my application of Dan Winters' work started to apply with the infinite golden circles seed of life drawing, which essentially took the seed of life and then built the golden ratio circles out. There's so many little tiny ones, and it can continue on and on and on. And that brought into the science of the implosion. I also have a video with him, Dan and Tufan, as talking about the golden circle seed of life as related to his work. And now what you can do is just picture this golden circle seed of life as if every circle within this had this implosive, explosive capability. And then all of a sudden, our original pattern has come to life in a way that is not just a flat hexagonal plane. This is really just a flat hexagonal plane, as this is too, because this is 2D, but I've just showed you with all these forms like this. And once again, reiterating that this is not possible drawing the incorrect dodecahedron and icosahedron that are in the original drawings of this pattern here, this flower, fruit of life, seed of life pattern, or Metatron's cube, the Metatron's tetraplex, or Metatron's golden matrix of infinity, whatever you want to call it. You don't have to put Metatron in all, but if you add golden ratio circles to this pattern that creates hexagons, it will start to produce the relationships between these forms as they are intended to be, as the building blocks of creation and the universal template that does that. And other people may discover other varieties of formats of these. This is just all I have to offer at this point. And the cool thing is you can do these same infinite circles from what I call the square view, the pentagon view, of course, and other variations. So let's just have a little fun with the models real quick. Here I am, I'm back. Thanks for joining me on the journey. So yeah, this is the little cube octahedron that I was showing in the video. There's the little central tetrahedron. There's like a flat section of the golden hexagon. As I rotate it, you see, all of a sudden you get that little space of a tetrahedron, but that's around the whole structure. And then once you take that, and this is what I'm talking about. I take one like this, the tetrahedron down in the middle. You flip the other one like this, the tetrahedron's up, and then you got these crisscross of these golden rectangle faces. I really have an affinity to this little straw one. I mean, here it is in the Zoom tools. It's doing the same type of thing. I didn't realize I could make this so easily. So anybody can make the golden hexagon with the Zoom tools of 3 different sizes, which are in phi ratio. And then this shape here led me to first making the paper model. And I described this, I plugged that into there. I started to put them together like this. But let me just take this one apart because I thought it was quite a special little model. It's so reminiscent of me look to the isotropic vector matrix, but this is the start of the golden vector matrix, basically, if I were just looking at it as one cube. So I can open up the top, those just go down flat on top of the other cubes, or the other shapes in there, tetrahedrons. There's the one tetrahedron. I got one at the bottom. Let me see if I can get the octahedron out. I got to take a bunch of tetrahedrons out. Okay, here they all come. And there's the octahedron. And now this shape, you'll see is starting to have all the hollow space with inside that. There's the other 4 tetrahedron that are still poking out of the bottom of the shape. So when I started to construct that, it just was like, oh, it's kind of like giving me these spaces, because each of these tetrahedron little caps that stick through, it's almost like these 3 tetrahedron are coming together, 4 tetrahedron come together, and they share that central tetrahedron. So there is no separateness, I guess, let's just say. Your tetrahedron, your star tetrahedron is part of a larger star tetrahedron that's connected to other star tetrahedrons. And that's a great way to think about connectivity and wholeness and relationship with other people. You're not an isolated little star tetrahedron anymore. Your tetrahedron is part of like infinite expanse of tetrahedrons. And here's the cube octahedron that was in that structure. And then, these would all just go on that around like that. And it just created the hollow spaces. So, this is also the same form that I was mentioning that that provides all the nodes to create the dodecahedron and icosahedron off of it. But it's just one. You need 4 more to get the full picture. And then let's see, here's the little quasi-crystal growth one that has the icosahedron off to the left there, the big one down at the bottom, the cube tetrahedron, there it is, there's a star tetrahedron in the middle of that. There's the other dodecahedron vertice facing you, the big white ball, the little dodeca is up there. And this is just one little piece of the larger structure that I will show you one more time in one moment. Oh, I have one more model down there. These are these two, the equilibrator, and I've got to find a cool name for this golden hexagon. This one is one of my most special forms to have discovered. Actually, it's called the non-uniform icosahedron. That's what it is. When I finally, after months and months of trying to find it in the bottom, buried away in some Wikipedia page, that's what they called it. But here is the other structure that has the golden hexagon cube octahedron creating the little star tetrahedron. Like there's the tetrahedron at the top. There it is. So that created a cube. Look, it's a cube, right? This perfect cube structure that's been created by that. And then these would be in, and I left a portion of the icosahedron on there. These would be in there. But remember, we've got this blank space over here. So that means there's another cube that has to be in there. There's 4 more cubes to complete this structure. And amazingly, if you had the right amount of Zoom tools and the right amount of connectors and the right lengths, you would find that that would all integrate and interlock within this. It wouldn't just like fight against each other to make that. So that one is really cool. I think the yellow really helps see that the cube is within that. And it in the icosahedron, okay, so this will be a good way to show that. If the icosahedron is straight on, do you see the way the black triangle had to turn? Because that icosahedron triangle is facing you. If I then rotate this way, the icosahedron has to go. See, now it may not be like that all throughout the universe, but if we're just building with the strict rules of this geometry as presenting itself, that's what happens with that rotation. And that's what I was talking about with the drawings, as if one had to be oriented this way and one would be that way. They weren't really compatible. And I believe that was it, except for the infinite phi golden matrix structure, which I wish I would be able to show you in person. Remember, this is Dan Winter's star mother model that has been completely dodecafied and icosified, to the nth degree, meaning that the implosion model is now off of every dodeca within this. This is kind of what DNA pictures even look like from a ratcheted top-down perspective. And it's got the icosa, it's got all the other forms, the square faces of that rhombiicosi dodecahedron. It's just a phenomenal structure that is completely described with, hopefully, very fully within this. So that was probably a full video. I hope you're still with me, or at least coming back to finish it up. But thank you so much. Like I said, if you're one of my subscribers, if you're not one of my subscribers, please consider subscribing and checking out my Patreon material where I show people how to draw a lot of these shapes and images. As well, I've got a 8-week apprenticeship that I teach people the drawing techniques, where we go over the forms and we start really from the basics, but it's all connected because you're starting off with a circle, a couple circles and a few lines, and the phi ratio circles. So I have a Facebook group as well, a new geometer, so check that out. But I think that's it for me today. Thank you so much, and much love and appreciation to all of you. Love to all, and have a great, fantastic rest of your day.